Hey there, science fans! Welcome to another exciting journey into the world of science. Have you ever thought about gases? These invisible wonders are more fascinating than you might think. They're invisible, but they're all around us. From the air we breathe to the atmosphere that surrounds our planet. We breathe air, which is a mix of gases like oxygen, nitrogen, and a bit of carbon dioxide. Every breath we take is a complex dance of these gases. We fill our car tires with air too. Helium makes balloons float, giving them that magical weightless feel, and carbon dioxide puts the fizz in soda, making every sip a bubbly delight. Pretty cool, right? Understanding how gases behave helps us understand the world around us. From weather patterns to how we cook our food, gases play a crucial role. Gases are important, and they can be a lot of fun. Think about all the fun experiments and demonstrations you can do with them, but they can also be a little tricky to understand. They expand and contract, they can be compressed, and they exert pressure. These properties make them both fascinating and complex. That's where the ideal gas law comes in. This fundamental principle helps us predict how gases will behave under different conditions. It's like a secret code that helps us unlock the mysteries of gases. By understanding this law, we can decode the behavior of gases in various situations. So are you ready to become a gas guru? There's so much to learn and discover about these invisible yet powerful substances. Let's dive in and explore the fascinating world of gases together. From their basic properties to their complex behaviors, there's a whole universe of knowledge waiting for us. The ideal gas law is like a magic formula that describes how gases behave. It tells us how the pressure, volume, temperature, and amount of gas are all related. And guess what? It's not even that complicated. The formula is simple. PV equals sign nRT. Don't let the letters scare you. We'll break it down together. This equation is like a superpower that lets us predict how a gas will act in different situations. Ready to unlock the secrets of this powerful equation? Let's keep going. Okay, let's decode this formula PV equals sign nRT. This is known as the ideal gas law, a fundamental equation in chemistry and physics. Each letter stands for something important, each one representing a key property of gases. P is for pressure. Think of blowing up a balloon. The air you blow in creates pressure that makes the balloon expand. Pressure is essentially the force that the gas exerts on the walls of its container. V is for volume. That's the amount of space the gas takes up, like the size of the balloon. The larger the balloon, the greater the volume of gas it contains. N represents the number of moles. A mole is just a way scientists measure a large amount of tiny gas particles. It's a convenient unit to quantify the amount of substance. R is the ideal gas constant. It's like a special code number that connects all the other variables. This constant helps us relate pressure, volume, temperature, and the number of moles in a predictable way. T stands for temperature. You know how heat makes things expand? Well, it does the same thing to gases. When the temperature increases, the gas particles move faster and spread out more, see? Not so scary after all. Now that we know what each letter means, we can start to see how they all work together. By understanding this formula, we can predict how a gas will behave under different conditions, making it a powerful tool in science. The ideal gas law isn't just some abstract formula in a textbook, it's happening all around us. Think about inflating a tire. You're pumping in more air, increasing N, which increases the pressure, P, inside the tire. The tire might even feel a little warmer because the temperature, T, has gone up a bit too. Or how about a can of soda? When you pop the top, you release the pressure, P, inside. That's why you hear that satisfying psst sound. The dissolved carbon dioxide gas, N, escapes and you see bubbles forming. These are just a couple of examples of the ideal gas law in action. Once you start looking for it, you'll see it everywhere. Section 5. Solving a problem, step by step. In this section, we'll break down the process of solving a problem into manageable steps, making it easier to understand and apply. Let's try a simple problem. We'll walk through each step carefully to ensure you grasp the concept fully. Imagine we have a balloon filled with helium. Helium is a light, non-reactive gas often used in balloons because it is less dense than air. The balloon has a volume V of 2 liters. Volume is a measure of the space that the gas occupies. It also has a pressure P of 1 atmosphere. Pressure is the force that the gas exerts on the walls of its container. And it's at room temperature T, which is about 25 degrees Celsius. Temperature affects the energy and movement of gas particles. We need to convert this to Kelvin, but we'll get to that later. Kelvin is the SI unit for temperature and is necessary for our calculations. How many moles N of helium are in the balloon? Moles represent the amount of substance, which is crucial for understanding gas behavior. First, we need to make sure all our units match up with the ideal gas constant, R. Consistency in units is key to accurate calculations. We'll use the value of R equals 0.0821 liters atmospheres per mole Kelvin. This constant helps relate the different properties of the gas. Next, we rearrange the ideal gas law formula to solve for NN equals PV divided by RT. This formula is derived from the relationship between pressure, volume, temperature, and moles. Now we plug in our values. N equals 1 atmosphere times 2 liters divided by 0.0821 liters atmospheres per mole, Kelvin times 298 Kelvin. Plugging in the values correctly is crucial for an accurate result. Notice how the units cancel out, leaving us with moles. This step ensures that our final answer is in the correct unit. After doing the math, we find that there are approximately 0.08 moles of helium in the balloon. This tells us the quantity of helium present. See, that wasn't so hard. Breaking down the problem into steps makes it much more manageable. With a little practice, you'll be solving gas law problems like a pro. The more you practice, the more intuitive these steps will become, and soon you'll be able to tackle even more complex problems with confidence. Section 6. Why is the ideal gas law important? So, why should we care about the ideal gas law? Well, it's a fundamental concept in chemistry and physics that helps us understand how gases behave. It explains why a balloon shrinks when it gets cold, why a tire explodes if it's overinflated, and how we can calculate the amount of gas needed for a particular reaction. The ideal gas law is a powerful tool that scientists and engineers use every day. It's used in everything from designing airbags to predicting weather patterns, and now you know how it works too. Section 7. Ideal gases versus real gases. Now here's a little secret. The ideal gas law describes ideal gases. But in the real world, gases don't always behave perfectly. Real gases have tiny forces between their particles that the ideal gas law doesn't fully account for. However, the ideal gas law is still a very useful approximation for many real-world situations. It gives us a good starting point for understanding how gases behave, and we can make adjustments for real gas behavior if needed. Section 8. Limitations of the ideal gas law. As we mentioned, the ideal gas law has some limitations. It works best at low pressures and high temperatures, where gas particles are far apart and moving quickly. At high pressures and low temperatures, the assumptions of the ideal gas law break down, and we need more complex equations to accurately describe gas behavior. But don't worry, even with its limitations, the ideal gas law is an incredibly useful tool that helps us understand and predict the behavior of gases in countless applications. Section 9. Applications of the ideal gas law. The ideal gas law has a wide range of applications in various fields. Chemists use it to calculate the amount of reactants and products in chemical reactions involving gases. Engineers use it to design engines, air conditioners, and other systems that involve gases. Meteorologists use it to predict weather patterns and understand atmospheric phenomena. Medical professionals use it to understand gas exchange in the lungs and to develop respiratory therapies. These are just a few examples of how the ideal gas law is used in the real world. Its versatility makes it an essential tool for scientists, engineers, and many other professionals. Fields. Section 11. Conclusion. The power of understanding gases. So there you have it. We've explored the fascinating world of gases and unlocked the secrets of the ideal gas law. We've learned how pressure, volume, temperature, and the amount of gas are all related, and we've seen how this simple formula can be used to explain a wide range of phenomena. Understanding gases is essential for comprehending the world around us, from the air we breathe to the weather patterns that shape our planet. The ideal gas law is a powerful tool that helps us make sense of this invisible but ever-present part of our universe. So keep exploring, keep questioning, and keep the spirit of scientific discovery alive.